everyone, and welcome back to the part 18 of our tutorial series where we are building our AI application with the RAG strategy with the multiple data sources. So far, we have integrated with PDF, URL-based data, SQLite DB, PostgreSQL, and the MongoDB. And in today's video, we are going to understand how we can integrate a new data source, which is most commonly used in the machine learning or the deep learning word, which is CSV data. Right, so let me just quickly show you the sample data which I have created. We have 3 columns in CSV: question, answer, and topic. So this is the question, and then we have an answer, and all those are related to the system design concept only, like database concept, scalability. So these are the 3. So what's the flow? It's very logical, right? What we need first, we have to load the CSV, extract the data. We are going to use the Panda library, so we have to install that. And then we are going to just create, based on the data which we loaded to the Pandas data frame, we will extract the specific column, create a chunk. Basically, we are going to create the content which we are going to fed to the document class of LangChain. Then we are going to create an embedding with the embedding models, and based on the batch size, just to handle the larger CSV file. And then we are going to load to the vector DB. And once we have a data loaded to the vector DB, then the flow is same. Whenever user is going to ask the question, we are going to create our context. First, we are going to extract more number of records with the vector similarity, and whatever output we get from vector similarity, we are going to feed to the re-rank model that is going to fine tune that output to just provide a more accurate context, and that context will create a prompt with the help of a question, and then the request will go to the LLMs, and then we will get the response, right? This is the very high level flow. So let's get into the demo part. So what we have to do, as usual, first we have to install the dependency, so which is very straightforward: pip install pandas. So I have already done that, right? And then we have to just build a backend code, right? So for backend code, we have to go our ingestion folder. So we are going to just create a new ingestion file. We are going to call this CSV ingestion. Right, and then as usual, I have already created the entire code base, which is very similar. It is just following the same standard. The only difference you will find in this is related to how we are loading the data, because now we are using a Panda library to just load the data. Right, so these service related import is same. We are just importing a config, right? And the function name is ingest CSV data to Pinecone, but you have to keep in mind we have 2 parameters: batch size and the file name, or the file which we are allow user to upload that, right? So we need only 2 fields in UI. We have to keep in mind. So I'm just creating this CSV file path, right? This part you can ignore because it's just checking whether the batch size is correctly given or not. So this is the part where we are just using a read CSV method of Pandas. So we are just importing Pandas as PD, and then we are calling this read CSV method and feeding the CSV file which we are doing from the UI part, right? Then again, we are just ensuring, whether we have this question and answer in a column. This is again just some logic to just validate the data is CSV file with the correct structure is there or not. So we are initializing embedding because we need that to just initialize our vector store, where we have the Pinecone index embedding in the namespace, right? And then we are using this text splitter. Text splitter is if you just come here, it's a recursive character text splitter from LangChain, which actually help us to just create a chunk based on the chunk size and the chunk overlap, which we have defined in our config.py, which you can see here, right? Then coming back here, then we are just iterating through all the records which data frame has. Once the read CSV method gets executed, entire rows will be in the data frame, and then we are iterating through each and every row and extracting or parsing the question and the answer. And then we are creating a content. But before creating a content, we are checking whether the question and this answer is not a null. Basically, it's a not blank, right? Then we are creating a metadata: source CSV, file name, and a row index. Row index is again the same index which we have in our data set, right? Once we have that, we are creating a batch docs, and then we keep checking whether the batch docs is matching with the batch size or not. If this doesn't match, so for example, if we don't have, let's say we have given 100 batch size. So if the length of this batch docs is not 100, then it is going to come here, right? Then it will just create the chunk with the less number of records, because we know the kind of CSV we have. And if we just give batch size as 100, then definitely we are not going to get, multiple batches, right? So where we have the data, we have this data here in CSV, right? So we have only 10 records, right? Cool. So it just split the document and it is going to give us in a batch chunk, and then batch chunk is going to be added as to the vector DB by this vector store add document method, right? Once we have this, then we are golden, right? Because our entire CSV data will be loaded to the vector DB, right? Then what we are saying, what we are doing, we are just creating a summary, and the suggested question is the same logic what we have been using so far, because once we have the data, the complete data, then for creating a summary and just creating a vast 5 questions, logic is same, right? It's no different, right? And rest of the stuff is just ensuring that if any exception happens, then we are just giving a right kind of error message to the user, right? So it looks lengthy, but it's very straightforward because I'm just following the same standard for what we have been following for other data sources. So this is from the backend perspective on here. What we have to do, we have to just import the CSV ingestion, and then we have to call a function CSV Data Pinecone, right? So this is what we have to import. And then here we have to add another tab which will provide us. So we know that, okay, for this function, we need 2 fields as an input, right? So now let me quickly show you that we have 2 fields, gr file and gr number, and we are saying upload CSV file, and file type is going to be .csv. Then this is for the batch size, and then we have 3 output fields, as for one for status, then summary, and the suggested question. It's pretty much same as what we have for other data sources, right? And that's it, right? And if everything is working fine, then we should be having working. Cool. Let's click on this. Let's change the setting to done. Cool. Now we can upload the CSV. We have okay. Now we can CSV. We can upload the CSV. This is my CSV. Okay, and then I can say 100. Okay, so we can just quickly run this. Come to the server side. Okay, so we can see CSV is red. 10 records found. Cool. Namespace just got cleared on Pinecone DB. Vector store initialized, text initialized, starting batch processing, right? So we just got only 10 records because we have our 100 websites. That's the first round of loading will happen. Okay, so now we can see, okay, what is the summary, and then we have a probable questions, right? We can quickly copy this question. We can just go to our ask question tab, and we can simply ask this question. I'm back here. Retrieving the initial document for question how to SQL, no SQL. So first it extracts 10 initial document based on the vector similarity. Then it fed to the re-rank model where we get the top 3, which is going to increase the accuracy of our context. And then the prompt will be created with the context in the question. And then it's calling a rack chain where LLM is being requested for the proper prompt. And then we have these retrieve context. These are the 3 contexts which just got added. And this is the answer based on the context provided. Structure SQL database are relational, while NoSQL database are non-relational and have different data models like document, key value, white column, graph. This completely makes sense. Schema SQL database have a fixed schema, whereas NoSQL database have dynamic schema. Cool. Scalability SQL database are typically vertical scalable, whereas NoSQL database have a horizontal scalability, which means adding more machines nodes to handle it. Perfect answer, right? So now we have added another data source, and now we have 6 data sources integrated. It means that we have just made our application more intelligent, having 6 different sources which are most commonly used in ML world or the deep learning or the AI tools, right? So that's it from my side for this video. If you have any feedback or suggestion, please feel free to put that in the comment section, and I would love to incorporate that in my future videos. And if you really like this video, give a thumbs up. And if you feel this video can help your friends, colleagues, and groups, please feel free to share with them. And if you haven't subscribed for my channel, please subscribe for my channel. As always, thanks for watching this. Stay healthy and keep learning new things.